Hello everyone, myself Arjun Pal and I am pursuing my third SEM in Computer Science and Engineering in Cybersecurity from Sri Venkateshwara College of Engineering, Bengaluru. Today we have been given the topic called ANOVA Techniques and Basic Principles. So welcome to this introduction to ANOVA, a powerful statistical tool for analyzing differences between groups. In this presentation, we'll explore its basic principles, common types of ANOVA, and how to choose the right technique for your research. First, introduction to ANOVA. Let's discuss what is ANOVA. ANOVA, analysis of variance. That's the full form. It is a statistical test that compares the means of two or more groups. It determines if there is a statistically significant difference between the group means or if the difference are due to random chance. The key concepts. ANOVA partitions the total variability in the data into different sources of variations, such as between group variation and within group variation. Let us understand the one-way ANOVA. First, one independent variable. The one-way ANOVA examines the effect of a single independent variable on a dependent variable. Second, multiple groups. The independent variable has at least two groups, allowing comparison of mean across those groups. Investing the impact of different fertilizers like group 1 fertilizer A, group 2 fertilizer B, group 3 fertilizer C on crop yield that depends on the variable. Assumptions of one-way ANOVA. First is normality. Second is homogeneity of variances. Third is independence. Normality. Data within each group should follow a normal distribution. Homogeneity of variances. The variances of the group should be approximately equal. Independence. Observations within each group should be independent of the variable. Interpreting the one-way ANOVA results. F statistic measures the ratio of between group variance with within group variance. A higher F statistic indicates greater between group variability. P-value. It represents the probability of observing the observed differences in means if there were no true differences between the groups. A low p-value, typically less than 0.05, indicates a statistically significant difference. Post hoc test, used to identify which specific groups differ significantly from each other, and ANOVA result is displayed. Let us understand two-way ANOVA, analyzing interactions. Two independent variables examines the effects of two independent variables on a dependent variable, allowing for the analysis of interactions between the variables. Example, testing the impact of different teaching methods like group 1 traditional, group 2 interactive, and student motivation. The first group can be high, group 2 can be low on the test scores. Interactions. When the effect of one independent variable on the dependent variable differs across levels of the other independent variable. Assumptions of two-way ANOVA. First is normality. Data within each group should follow a normal distribution. Homogeneity of variables. The variances of the group should be approximately equal. Third is independence. Observations within group should be independent of one another. Now, interpreting two-way ANOVA findings. Main effects. Indicates whether each independent variable has a significant effect on the dependent variable. Second, interaction effects. Reveals if the effect of one independent variable on the dependent variable is different at different levels of the other independent variable. Post hoc tests used to identify specific group differences or interaction effects. ANOVA with repeated measures. Repeated measures used when the same participants or subjects are measured multiple times under different conditions or at different time points. Example, measuring participants' stress level before, during, and after public speaking task. Advantages: increase statistical power and reduce the confidence use of the same participants. Now, selecting the appropriate ANOVA technique. First, independent variables. How many